Hey all you guys, gals, and physics pals. Welcome to Quantum High, modern physics for high schoolers. Now let's get talking. Now, I know a lot of you have probably heard of the Doppler effect regarding ambulance going by going, change in pitch. But there's also a Doppler effect in light. And it kind of does the same thing, but on a very, very different mechanism. So the Doppler effect of sound is just regarding to the speed of the observer and the speed of the source, and then the speed of sound itself. But the speed of sound, changes with different mediums and stuff. But the speed of light, as we remember, is always constant, which is the key difference there. And so this Doppler effect of sound is F equals speed of sound minus the speed of the observer over the speed of sound minus the speed of the source time. And then, so that's how you get your, time is frequency, but that's how you get your new frequency for depending on how fast everything is going. But the Doppler effect of light is based off of the Lorentz equations, Lorentz transformations. And so the basis of the Doppler effect in light is that you have an object that's emitting light in one reference frame, and then you have the observer in the other. So the Doppler effect is equal to F equals, so the frequency, equals, I've forgotten, 1 second. The Doppler effect frequency equals the square root of 1 plus or minus V over C, all over 1 plus or minus V over C, which is times the frequency in the source frame. So this results in a very seemingly simple calculation, because if you remember in your class, you learned that beta equals V over C. So you just get F equals the square root of 1 plus or minus beta over 1 plus or minus beta. Defining that in terms of wavelength, we get the new wavelength equals the square root of 1 plus or minus beta over 1 plus or minus beta times the original wavelength, when beta equals V over C. So this results in that if the object is moving towards you, the numerator of the square root is positive and the denominator is negative, but if it's moving away, the numerator is negative and the denominator is positive. This flip of signs results in that red shift and blue shift. If it's moving towards you, and it's going to blue shift, and if it's moving away, it's going to red shift, because longer wavelengths equals red, higher wavelengths is blue. How this red shift and blue shift and Doppler effect of light is used in the world is there's so many applications. There's applications in astronomy, looking out into the universe and seeing and proving that the universe is expanding through seeing the different wavelengths, things coming toward us, things moving away, a lot of red shift. There's also applications in laser cooling and LiDAR, and so many other cool aspects regarding the Doppler effect. Now let's get on into the outro. That's all for the video. Hope you learned something. I'll give you a quantum bye. Get it?